Right, in the last video, we were looking at doing arithmetic combinations of functions. That's using adding, subtracting, multiplying, and dividing. But there were problems where we were given the equations. And another piece of it was to determine the domain of the functions. Okay, and I thought I should have mentioned something that I didn't before. You have to be careful when doing the domain. You really do need to kind of think about it like you've got these two functions next to one another and think about whether you're making it all the way through those two functions or not. Okay, your overall big function machine contains those other two. Okay, I say that because if you only looked at the simplified version of f divided by g of x and tried to do the domain from there, you really only see one trouble spot, and that is the radical. And so you would probably get the -2 to infinity piece correct, but you don't really see that 0 is a problem. In the overall simplified answer, you don't see a denominator, so you might not rule that out. But you actually do need to look back at the fact that the g function, to get through the g function right there, okay, x couldn't be 0. See, it would make the denominator of the g this. It would make the little x would be 0, and so -1 divided by 0 would be undefined. And so be careful about that. Don't just look at the final simplified version. You have to think about how that function came about. You have to actually go back to the individual two pieces and think about it that way. That would have been incorrect. The domain actually needed to be -2 to 0, and then from 0 to infinity. Anyway, that's not really the point of this video, but I noticed it when I was getting ready for the video. All right, what I really want to do in this video is look at a couple of really fun situations. What if the representation we're being given is a table or a graph, and we're being asked to do arithmetic combinations of functions? Okay, that's what we're looking at in this one. All right, so if you have a table and you're being asked to do something like f plus g of 2, you should just be thinking, I need f of 2 and g of 2, and then I'll add them. And so to understand this table over here, do you see the x? That's the input. And then these two columns is the definition for the f function. And then x together with this gives you the input and the output for the g function. So they just kind of, instead of having to write all those x values a second time, they just went ahead and consolidated the table like this. So if I want to know f of 2 or g of 2, I need to use an x of 2. So there's f of 2. 4 is g of 2. So I'm going to take the 7 and the 4 and simply add them. Okay. Then g minus f of 0, make sure you do the g of 0 first, f of 0 second. Subtraction's not commutative, so you have to be careful about your order. You're going to look at this row. G of 0 is -1, f of 0 is 5, and I'm subtracting those. Okay, so I'm going to wind up with a -6 on that. All right, f times g of 2. I need to do f, -2, I mean. F of -2, g of -2, and multiply them. So I'm looking at this row. F of -2 is 0. I almost don't need to go any further. I know the overall answer is going to be 0. And then be careful here. Make sure you get the f of 0 on top and the g of 0 on the bottom. Okay, so f of 0 is 5, g of 0 is -1, and 5 divided by -1 is -5. All right, so tables are kind of fun because you don't have a lot of arithmetic work to do. You just have to make sure you're interpreting the table correctly and you understand about x being where the inputs are. These are your x's here, okay? And then the f of x and the g of x, make sure you look in the appropriate column. And then be careful about subtraction and division because it does matter what order you do those in. All right, and then I want to come back up and look at combinations of functions using a graph. Now this is usually a little bit more tricky for people, okay? See how the parabola is labeled with a G? And this is just a whole bunch of ordered pairs that could have been in a table, or they could have given us some kind of an equation, but they didn't. They just gave us the picture. And then the f function is the line. It's also a whole set of ordered pairs. So be sure to think about that, okay? All right, so if we want f plus g of 0, we just are going to do f of 0 and g of 0 and then add those two together. But it's finding the f of 0 and finding the g of 0 that you're going to find to be a little more challenging, okay? Because you don't have an equation to plug into and you can't just pull it out of a table. So for f of 0, make sure you're focused on the line. 0 is an x, so you're looking at on the x-axis where 0 would be located, and then you have to go to the line, and it just happens to go right through that spot, so f of 0 is 0. Now, when you do g of 0, your analysis should be, okay, 0 is my x, so I go to here, but then I have to go to the function. I have to look for an ordered pair that's actually on the g function here, okay, that has an x of 0, so that would be right there. And you know that point is 0, 2. So g of 0 would be 2. That would be 2. And then you simplify that, 0 plus 2 would be 2. That's your overall answer. Okay? All right, so let's try another one. Let me kind of clean this up so it's not messy. And let's think about the next one. Okay? So we're going to do f, oops, I wanted that in red, f of negative 1 minus g of negative 1. The x is negative 1, so that means you should be over here at an x of negative 1. When you try to find the value of the function f at negative 1, the f is the line. You have to drop straight down to get an ordered pair that has an x of negative 1. There it is. And then you read off the y-coordinate, which appears to be negative 2. But to find g of negative 1, you still are going to go to negative 1 on the x, but the g function, to hit it, you have to go straight up, and that'll give you the ordered pair, negative 1, 1. So you know g of negative 1 is 1. And then we were subtracting, and so our overall answer would be negative 3. Now, we could be plotting these new values we're finding. We could find a whole bunch of them and wind up creating a graph for f minus g of x if we wanted to. We just aren't going there. All right, and then fg of 1, we just do f of 1 and g of 1. Okay, so let's get our bearings again. So 1 is an x value, so you should be focused here to start with. Okay, to get f of 1, you have to hit the line. So make sure you go all the way to the line, and then you read across the y-coordinate. So that would be 2. G of 1, you go to 1, but you stop. You stop when you hit the parabola, and you see that the y-coordinate would be 1, and then you multiply those two together, and you get 2. Okay. All right, and then we have g of negative 1 on top, and then f of negative 1 on the bottom. We already analyzed the negative 1s before. I'm almost just going to look up here. G of negative 1 was 1. F of negative 1 was negative 2. So 1 divided by negative 2, that would be a negative 1/2. Okay, so we went to negative 1, and the g of negative 1 was 1, and the f of negative 1 was negative 2. And then you just simplify it. And do make sure you put the g function on top. Okay, so that's combinations of functions. Sometimes you're going to be given just a graph, sometimes just a table, sometimes an equation. And then occasionally you're going to be asked to determine the domain. Okay, and the illustration that we looked at here is an important picture to have in mind, because the idea, let me go back to the snip of that, because the idea there is for you to see that you have to make it through F, you have to make it through G, and then you also have to watch out on the division ones that you don't introduce even another trouble spot. But it helps you to see that the two functions are next to one another. And so when you're analyzing domain, you have to make it through each function, okay? And then on divided by, you do have to consider anything that would make the denominator 0, okay? All right, so those probably aren't going to give you too much trouble. I want to do a video now on composition of functions.